it's a challenge. So make sure you spend a lot of time, expect 10, 12 hours a week in this class, all right? So look at the first one. The first one is really gentle, actually. Tutorial 1 is very gentle, okay? What is being covered over here? Task 1 is really simple, just a several delay. You don't have to, dig too deep into that. It's just very simple assembly code and nub. So this is assembly, just do nothing command in there. The goal of this is we are creating a microsecond delay function by ourselves. And how do we know it's gonna be a microseconds? So for every single one, it's giving you 1 microsecond. So the way to do that is you insert a bunch of them in there first, and then you measure it from the oscilloscope. So microcontrollers, if you are dealing with micro-embedded systems, you're developing a system, you cannot just directly code up the C programs. You have to work in the lab with all the benchtop equipment, including oscilloscopes. You have to know deeply how to use it. You must be masters after this semester. Okay, so how do we measure it? There's an example code. Like I said, this one is easy. Okay, so task 1, the code is given. As long as the board is working, you upload this one to the board, and it's going to blink. If you see that the buttons and the LED, I define 2 pins, and these are the pin numbers. It won't be the pin number. It's a little bit confusing. Let me show you one of the graphs over here. I already posted. Pin map. So every 3 credit class requires you like 9 hours a week, right? If I'm saying 10 to 12 hours, not too bad. Okay, so it's not too much. Just let you know, at least 9 hours that's required for 3 credit class. Okay, and given that this class is so useful, I mean, it's reasonable to spend a bit, like a couple more hours in there. So look at the pin. If you look at the pin of the microcontroller, 100 pins, and they all have their names. So the ports include like D ports, J ports, H ports, A ports, like PA, PPP. But for other very simple microcontrollers, you won't see like H and J, because usually they only have a 28, 30 something pins. Usually like a B, C, D, and that's it. Not even E ports, because every type of port, the the ports have 8 pins, usually from port 0 to port 7, like 8 pins, because the 8-bit microcontroller, all the memory banks are 8 bits. And for this one, it's different because there's so many pins, so it goes up to like H and J and all these kinds. So I understand what's going on. So these are the pin names, and they have their functionality in the parentheses, like TX. Very quick quiz question. So what is TX and RX? What are they?
Transmit, receive.
UART, right? Yeah, transfer and receive, and they are UART, serial communication. UART, universal asynchronous R. What is R? Receiving and transmitting, I think. UART. Okay, so UART is a typical serial communication, and that's what we did with the serial monitor reading and display. So RX and DX, these are the functionalities of the port, but they can also be used as basic digital GPLs. You can toggle it by writing a 0 or 1 to it. And however, the EDA, that's why we are using the Arduino's programming software, and that software is able to translate the pin numbers to these pins. There's an address of the pins being converted on the back of the scene, and we are not able to see. So when you program it, you assign a pin 9, number 9, in your code. It's basically this pin, PH6. But you don't deal with these PH6, all these kind of things, too many of them. You won't be able to identify. So what we do is just 1, 2, 3, 4, okay? And this is the pin 9, right? Pin 9. And in your code, if you program an Arduino IDE, and you just need to put if you want to use that pin, just directly put a 9 here. So 9 will be PH6. So you're using that PH6 pin by defining a 9 to this name. So you are basically giving this name. So this button pin, the name, is basically pin 9. Okay, same for the LED pin. The LED pin will be pin 3. So this experiment is doing what? It's doing like you press the button, and it's gonna start blinking the LED with a certain frequency, and that frequency is defined by this microsecond delay function. So ignore this one. So I don't think this is doing anything. It's just adding a little bit more delay to make it accurate. Yeah, but you don't have to add this here. It's not doing anything. Okay, ignore this one. So these are not just doing nothing, just waste some time, right? You add a bunch of them. If you find out on the oscilloscope you need a more delay, you just insert more. If you need a less delay, you just delete some of them. Okay, I don't know how long for each. You can measure it using the oscilloscope. And you can see it's a nested for loop. Here's a millisecond delay, right? You carry that argument into this function, and this function calls the microsecond delay for 1,000 times. So it's if this function delays everything for 1 microsecond, so if you give a 1 here, it's gonna do it for 1,000 times, which will be 1 millisecond. Do you know what I'm saying? It's a nested for loop, right? So we are assuming this guy is creating one microsecond, and because I have 1,000 times to run this microsecond delay here, if I call this millisecond delay, right? I put a 1 here, and then it's gonna call this microsecond for 1,000 times, and will give you a 1 millisecond delay. Okay. So that's a nested for loop for these two functions. Eventually, it will give you 1 millisecond delay. See here. And if I put 1,000 for the millisecond delay, what's going to happen? It's going to be 1 second. Okay. So we're doing two nested for loops, right? So one is 1,000 millisecond, which calls another 1,000 microsecond delay. So eventually, it's a million microsecond, which is 1 second. So they are creating 1 second time delay by using the millisecond delay function. So this function is an embedded function in the Arduino IDE. Is a digital write. You will deal with this a lot. So digital write is writing a digital signal like 1 or 0 to the pin, LED pin. So what's the LED pin's pin number? Instantaneous memory. 3, yeah, 3. So it's writing that pin 3 up and down, right? So what is this doing? Digital read. So it's reading the LED pin, so the current LED pin is holding a digital value, and reads it and then invert it. Okay, so reads it and invert it. So it's actually toggling the LED pin. So it's toggling that pin 3 once per second. So what's the period? 2. Right? Toggle. 1 second, 1 second. So period, 2 seconds. Make sense? And you have to know that in order to do the measurements. So that's everything for the code. That's it. We don't really have. Oh, there's another thing you need to know. Remember setup. You need to set up the pin mode. That's the Arduino specific thing. The pin mode button pin. Button pin is taking in the data from the button. You press it. It's being read. So whatever signal you are giving through the button will be read into the Arduino as a signal, right? And so that's why it has to be input mode. And if the LED pin is toggling the LED, so it's outputting signals, it's the output pin. And in the loop, it's a dead loop. After executing the setup function for once, it enters the loop function and keep going back and forth. And you can see that, we digital write the LED pin, we turn it off, write a load to it, turn it off, and then it stays here. So if you don't push anything, okay, you turn it on, you plug into the USB, it's gonna stay here forever. Remember the while loop? I end it with a semicolon. So there's nothing in the while loop. It's a dead loop. And it's high. Why is high? If you look at the schematic. Remember what's the button pin? What is the button pin? Number. Button pin number, what is that? Button pin name of the chip. So button pin is the pin 9, right? So what's the pin 9's name on the chip? pH what? pH 6. Which one? The bottom pin, the bottom button. Okay, so you have the board has two buttons on the left, a top one and a bottom one. It has a label on it, so you can see the top, bottom, and you are using the bottom one to control it because that's the pH 6. It's shorting to this pin. If you don't push it, what is the signal being read from pH 6? What is the signal if you don't push it? No, it's over here. It's being put up to VDD. What's the name of this resistor? R16. What's the name? Yeah, pull up. It's a pull up resistor. It's pulling this up. This is disconnection. If you don't push it, it's disconnected. So there's no current from 5 volts. It's disconnected from ground. So there's no current. No current, no voltage drop, right? No current, no voltage drop. So 5 volts here, 5 volts here. You're getting 5 volts. So in that case, it's going to be high, right? It's going to be high. So if you look at the code, am I doing too fast? Questions? Feel free to ask, okay? I'm sure even though some of the students are answering questions, but I'm pretty sure like 50%, 50-50, okay? 50% are following, 50% are not. So feel free to ask questions. It's helping other people as well. Anytime, okay? So this one, if I don't push it, yeah, it makes total sense, right? Because if I don't do anything, it's gonna stay here, right? You turn it on, it's gonna stay here because it's high. It's a dead loop. You push it, what's gonna happen? You push it. You push it short to the ground, okay? It's gonna stay here. And you think you are pushing that really fast, right? So the microcontroller is not paying attention, you can skip it. No, it's running at 16 megahertz. You can never beat 16 megahertz. Maybe Superman can do that. You can never beat 16 megahertz, okay? Just scanning through everything super fast. You push it, you release it, even though it's only 0.5 seconds, it's already scanned for like millions of times already. So keep reading the data here. You push it, it stays here. So when your finger is still holding that button down, it stays here because that's the low. It detects the low and it's a dead loop. It's gonna stay here, and then you release it. What's happening? It becomes high again, and this while loop. Keep in mind, there's no semicolon because you do need to do something, right? So when you release it, it becomes high again. So you need a curly bracket to have all the behavior, all the actions in here. That's how that works. So it's detecting that push and release action, and it will stay because after push and release, will stay in high afterwards, and it's gonna stay in this while loop. It's a dead loop. All right. So what is this dead loop doing? It's toggling that LED pin and delay it for 1 second. Okay, I'm assuming that I have a correct number of knobs in here, so it's gonna give me a accurate 1 second time delay here by doing 1000 milliseconds. However, it could be inaccurate. How to probe it? Which one you want to probe? Which one to probe? It's just LED pin, right? It's LED pin. Because it's toggling this LED pin every second. It's output, right? So output, you just probe it. It's output. You probe it, you will see a toggling waveform. What's the period? 2 seconds. Okay? You can just, try it. It's probably not exactly 2 seconds. If it's not, you have to come back and try to fix it. How to fix it? Come back here, shows you how to do that. So one more thing before we do get into that point. So you can use LED. You can connect a individual LED on the breadboard and toggle it, or you can use. If you look at this one, it has a header pins on the board, and it's a RGB. It's RGB LED. It's the one at the bottom left corner. You see a little LED. That's a RGB LED. It has 3 LEDs in it, 3 colors. It's mixing the 3 colors and giving you different colors. It's going to be a really interesting lab, probably tutorial 4. Okay, it's called Color Cube. It's really interesting. So you don't have to use all of them. If you just connect it to one of the pins, just showing red, you can blink that little LED only with the red color, which is fine. Okay, and Jesus Christ, it's using 2.2 ohms? It's probably gonna burn it. We'll see, huh? I know, but I forgot if that's the right one we should use. Usually, like, it should be 220, like several hundred ohms for at least. I forgot. Then you can use the onboard LED or use the LED on the you plug into the breadboard. You know, either way. Okay, so how do we measure it? I was assuming 10 knobs is 1 microsecond, so I do this to create 1 second half period to toggle the LED. So I do this first and then I measured it. Okay, so you should do that first. So I got 1.305 seconds instead of 1. Because the period is 2.61, not 2. Okay, and so do that first and see how much difference between your goal. So I want to fix it. I start with 4 knobs and I measure it. And I change to 10 knobs and measure it. 20 knobs and measure it. And I use a linear regression calculator. And eventually calculate it and eventually find a linear curve. Is that linear? It should be linear, right? It should be linear. So you don't have all the values, but you plot it and then you got a function. And then you calculate back, see how many knobs do you need. And I got 5 knobs for 1 microsecond delay. And that was from the PIC microcontroller I did at mine last year, not for Arduinos. Keep in mind, it probably won't be 5. But both of the microcontrollers are running at 60 megahertz. It might be very close. If you're getting 5, don't surprise. It's probably very, very close. Try it. You have to get a function, show the snapshots in the report. You cannot just directly tell me, oh, it's 5 knobs, because the tutorial tells you it's 5 knobs. So that's task 2. Task 3 is the Morse code. The Morse code is using that when you calculate it, you put a certain number of knobs in the microsecond delay and try to create a Morse code Morse code alarm. So the way that works is, you can see this is Morse code. Okay. How can I tell the difference of dot and dash? Like A is dot dash. So the only way you can tell is the period. Right? Do you can usually tell. These are different, right? So do that little one, the short one is a dot. And do that longer one is a dash. You only have 2 different symbols. So just use a period to show the different symbols, represent different symbols. So how do we do that? It's basically just you turn on that pin, because that pin is driving that audio amplifier. It directly connect to it. You don't have to modify anything. It's directly connect to it, and then to the speaker. You have to connect the speaker to that output. So if it's on for that certain time delay, it's a dot. And then you turn it off. For the it's called intermarker delay. If you don't have a break in the middle, you wouldn't be able to tell as well. Even though it's a do, right? You can notice that I stopped in the middle a little bit, so you can tell the 2 different ones. If you don't have a break, it's basically just a do all the time. Just we don't have a difference on the frequency. You know what I mean? So for to complete this letter A, you need a 1 sound and break and another sound. So the break takes a certain amount of delay as well. So you have 3 different on signals and 3 different time delays. It's actually really simple. It's basically you do a digital write, you delay it with a certain amount of delay. If it's a dot, you do this amount. Okay. If it's a break, you do this amount. That's it. But delay has to be off. So it's basically, for this one, you'll turn it on, okay, for a certain amount of delay for that dot, and you'll turn it off for the break. And you'll turn it back on again for the certain amount of delay for the dash. That's the ladder. And there will be an inter-ladder delay as well, since if I'm doing SOS help, right, there will be delays in between the ladders. So that one has a different time delay as well. You just turn on delay, turn on delay. It's really simple. And I have an example code for you guys over here. Okay, so we're still using the pin number 9, and we switched it to pin number 2 because I found out pin number 3 has issues. For the board I have, the Kai soldered. I don't know if it's the same issue for you guys, so I switched it back to pin 2 instead of pin 3 for this example. So I define these variables. So one time unit is, let's see, how long is one time unit? It's 200. So I just use multiples of time units to make it a little bit easier. You don't have to use this format. But I'm doing time unit, I set up a one basic time unit, 200. So 200, if you see the time delay functions I'm using, they're all millisecond time delay. So basically one time unit is 200 milliseconds. It's 200 milliseconds. And I'm setting up all these different types of time delays for multiples of the time delay unit. For example, dot time delay is 1 times 200, so it's basically 200 milliseconds. And dash is 3 times. Interladder delay is 3 times. Word pulse, do you need a word pulse? Yes, because SOS is 1 word, help is another word. You need a time delay over there as well. Okay? Intermark delay, which is the delay between dot and dash. It's a one-time unit. So it's basically giving certain numbers of milliseconds to these names. That's it. And the programming strategy, the major strategy is already given to you guys. Has a lookup table with all the letters. Okay, and since you want to enter the certain entries of the lookup table, you need to know the row number of it. Like A, right? A is going to be row 0, but how do you know that? I mean, for this a given message like SOS help, you definitely know the letters. The letters are given, so you have to convert the letters into the certain number of rows, the row index, the row address. So basically, you're converting letters into a row number first. So there's a function called convert. So this function converts. It's your code, right? You have to fill it up to convert a letter into a number. So remember we did convert uppercase into lowercase. We have done that, right? Convert lowercase into ASCII. So now it's your task to convert letter to numbers. For these certain tasks, I don't mind if you just ChatGPT it. I design all the labs to make sure that you guys cannot ChatGPT everything, but you know we have all the tools. Why not? I mean, it's just the core calculation of the function, but you still have to insert your own code, right? You are using AI to whatever, I think who said that? Is that Elon Musk or whoever said that whoever is losing their jobs is not the people. It's not everyone. It's the people who are not using AI, right? AI is not replacing every single job. It's whoever not using AI will lose their job. So we will use AI. It's okay. You can never use AI to generate everything for this lab because it's impossible. But for this single little thing here, it's okay. Okay, do it. Find out how to do that and plug it in. Make it compatible with your code. Convert. So it converts into row numbers. So you can, whenever you detect that letter, you enter that certain row, okay? And the thing is, you don't know how many columns it may have, but you do have an end as a mark, okay, or flag. So you can define the for loop to scan through all the columns for the longest one, like 6 or something, because the longest is 6. But you're also doing during the loop, you are also doing a check, right? If statement. If it's already end, you detect the end, then don't keep doing the for loop anymore. Okay, just stop. So you're detecting the end. If it's not ending yet, it's not detecting the end, then you have a nasty if statement, if it's a dot or if it's a dash. You're thinking, oh, it's too complicated. It's given. It's given. Making your life a lot easier. See here. The convert function you are going to ChatGPT will return a value to I that's a real number. You can do that, and that return value will be used for here, because I will be placing here, and you're detecting, oh, if it's not end yet, let's see if it's a dot. Okay, if it's a dot, I'm gonna do this amount of delay and end it with the intermarker delay. And if it's a dash, I'm gonna do this amount of delay, and then with the intermark delay as well, just afterwards. Okay, if it's not dash or dot, I just directly give a column number to 5 to end it. Because the longest one is 5, I just end it. Give a 5. It's gonna end it. Take some time to look at the code. A lot of times for all these new code, you just need to stare at it for like 1 hour or something to understand all the details. If you're not familiar with the code, right? Just stare at it. Think about it at the same time. Don't get distracted by TikTok. Keep in mind. A lot of the college kids now have ADHD right now, I understand. Whenever you're tired, where's my phone? Got anxiety. I need a TikTok. Where's my phone? I want to, steady, stare at the code so you can get it done. What else? Morse code example is provided. Results. One more thing. It's not given too much details about it, but what I want to show you is how to make the sound, right? So the template is asking you to do this, like a dot, right? Dash. Okay. So what I'm doing is I turn it on. There's a intermarker break. I turn it off and turn it on for this long. So the dash, for example, takes this much of time delay. The dot takes this much time delay. So just turn it on. So the result becomes, if you just turn it on and off, okay? So the results becomes this.
I just removed the...
Can you hear that? Right? Because just on off. The speaker is actually an actuator, right? So it has a magnet inside. We'll turn it on, it's doing this. It's attaching to the top. Turn it off, it getting released. And I'm thinking about another strategy. So for a dot and dash, that represents the length of the time delay. You do this. And then break, okay? Then, just do this, oscillations, you know what I mean? So how to do that? It's can be managed by a function. And the name of the function, why this is more significant? Because it's not, instead of just doing this, your speaker is this. Okay? It's doing this. So in that case, it's actually creating oscillation. It has a higher pitch. So if you listen to this.
Still the same task. Still press the button.
Okay. So it's more significant, right? So what's happening is it's just instead of giving on off, it's like doing this. It's just oscillation, still 5 volts oscillation. Okay, so another reason why, if you're interested in that, you're not, you are. Let me show you why. Okay, if you look at the audio amplifier circuit, here's the audio amplifier. So here's the input. Here's the input. Okay. So when you turn, here's a speaker connection. The speaker has 2 terminals. It's connected to 2 speakers. Use a screwdriver, screw it in. Okay. Here, and this is powered on with 5 volts. So the sound, whatever it's this, right? It's being put in here, or it's a higher oscillation. So the difference is if it's just doing on and off, you see this is a high pass filter, it's a capacitor. So it only detects that rising edge of the on signal. It's giving a pulse. So the high pass filter will filter out that step function into this, because the rising edge is considered as a varying signal. So that rising edge will pass that capacitor. However, after it getting steady afterwards, it's just nothing. So it's actually charging up the capacitor and then discharge after that DC signal. But if you are doing this, it's going to pass that capacitor and give you a way higher pitch and signal. That's why it's so loud, right? That's another reason for that. So one thing you need to do is there's a little jumper. If you don't, I think I have it in the drawer. It's a little connector. So you have to jump, have to make the connection from here to the other side. There's probably a video frame that I can show you here. Oh, we don't have a quiz today. Did I tell you that? Okay, so the quiz is on Friday for C programming. So study the in-class exercise 1. Oh, 2, right? So the programming one, not the digital one, not the logic one, but the programming one. And oh, look at it. Take a look. You see this guy. Oh, not this guy. This wait.
Still the same task.
No. I think it's this guy. This guy. So you have to put a jumper here. This is for the IR. This doesn't have to be on. So don't usually do this, because just in case it's emitting IR, it couldn't see, it's getting super strong because it's running a lot of current. This, you want to disconnect this. But I think it's this guy. Okay? This jumper need to be short. Can I take a look at yours? Thanks. Yeah, it's the one on the top. Yeah, this guy. So you need to short these two guys in order to make a am I right? No. So okay, I got it now. So remember, we chose LED number 2. Doesn't matter which LED, which it's not really LED pin. It's just a digital pin. Okay. So the code is here. LED 2, right? LED 2. I name it as LED, but actually it's not doing LED function. It's just a LED. I just name it LED. You can call it speaker pin, right? Doesn't matter. So it's pin number 2. So where's pin number 2? Where's pin number 2? Go to pin map. Pin number 2. Look for it. Here. PE4. Okay? PE4. But I think Kai labeled all the pins as all the numbers. 1, 2, 3, 4. You can find out number 2. So where's pin number 2? You can find it. It should be on the top. It's actually the one I used. So that's the one I used. You can use that one, right? So which is
Still the same task.
this one, right? It's this guy, pin number 2. That pin number 2, you can find it. And that pin, you need a jumper wire and short it to, I think that's the one at the bottom. That's the audio amplifier's input. So this is actually driving the audio amplifier and giving output to the speaker over here. Make sense? That's the only hardware connection you need to do. Similar for the LED pins. So I assume that, so here's the RGB LED. If you want to use the LED outside of the board, which is fine, okay? But if you want to use this RGB LED, interesting. Well, so we have to find out the pins over here, you know what I mean? So the RGB LED, you'll see different colors, schematic. Let's take a look. So these are, so he did have a connector here. It's a 1, 2, 3, 1, 2, 3, JP3. So JP3. So he doesn't have any connectors next. Oh, he does. Are these? Yeah, I think these are the connectors for the LED. So here's a RGB LED, has 3 colors in it. As you can see, these LEDs are shorted to the 2.2 ohm resistor. I think we probably need a different resistor.
Looked it up, and it should be 150 on the bottom, 100.
These?
Yeah.
Shouldn't they be the same? Where did you look that? Where did you see that?
The data sheet.
Okay, cool. Let's try it, but definitely 2.2 is too small, I think. He probably didn't see a correct value somewhere from the reference. So RGB resistors, pins. So you can drive these pins to toggle these LEDs, but definitely replace the resistor first. Okay, so you can find out the recommended resistors through the data sheet of this LED on DigiKey if you want, but pick up a reasonable value like 350 or 400 or 500 should be fine. I don't think it's gonna make any differences. Yeah. But 2.2 is probably too small. All right. Any questions on anything? I think I covered pretty much everything. What's up?
On the quiz, will it be pseudocode or Arduino code?
Arduino code.
Okay.
Will be at the very beginning of the class on Friday. Okay, we'll do the quiz here first, and then we'll go to the lab to do all the oscilloscope stuff and measurements. I'll help you guys on how to do that.
It being Arduino code, do you also want like void loops and void setup functions, things like that, defining variables at the top?
I think so. Yeah. I forgot what I put on the quiz. I did it 2 weeks ago, but but I will see if we need to do that. If not, maybe just the core portion of the code will be fine. If you show the functionality of it, probably we can ignore all these printing and all these serial setup things. Okay. Cool. It will be a very similar problem from the whatever we had on that in-class exercise. Won't be anything beyond that. Okay. Questions? We still have 10 minutes or so we can work in the lab. If you need my help, I can help with the soldering a little bit.